And welcome back to the next video in the series where we're going to look at branching in LMC. So how do you think we could achieve multiple subtractions in LMC? So I'm saying counting from 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 like the program on the right is. Now this has been done in LMC, it does work, so you can do it. So have a little think, how do you think that is possible in LMC? So hopefully you've guessed it correctly, and we're going to use some form of loop. Okay, now in LMC, loops and if statements are sort of the same thing, and it is called the branch command. So branching allows us to change the program counter to a different instruction. Okay, now it's the only LMC instruction that allows you to change the program counter, and this has been a common exam question. You know, which name a command that changes the program counter, and your answers are any of the branch command, which is BRA, BRP, or BRZ. So if we branch to a later instruction, then we're acting like an if statement. So instead of, say we're on instruction 1, we might go to instruction 2, or we might go to instruction 6. That's like an if statement. However, if we go to a previous instruction, so we're on instruction 5 and we go back to instruction 0, then that's acting like a loop, depending on which command you use. So we've got BRA, which is branch always, so every time it gets that command, it'll jump to the instruction that you specify. So in that second example, where we get to instruction 5 and it jumps back to 0, that will run forever, continuously. Now branch if 0 will jump to the specified instruction if the accumulator is 0. And then we've got BRP, which is branch if positive. However, 0 counts as a positive number, and it'll jump to that specified instruction if the accumulator is positive. So this is the code that we wrote. This is the code that did that counter that you've already seen. So we've got INP, out. I've named the second command, because we start at 0, counter, and we store that in a variable called start, and then we sub a value called decrement, which we can see is a dat of the value 1, so it takes away 1, outputs the value. Now we get to a branch command saying, basically, if the accumulator is 0, then jump to end. End goes to the value, the instruction of HLT, so it'll stop. If it's not 0, it just goes to the next instruction, so it goes to another branch. So if it's positive, which it will be, the first time it goes around, it'll be the value of 9. It then goes back to counter, which is here. Okay, so this one is basically acting as an if statement, and this one is essentially acting as a loop, because this one jumps forward, this one jumps backwards. So essentially the same code as saying if value equals 0, stop. And this is saying essentially a do while loop, whilst the value is still positive, keep doing what you're doing. So you see, in a bit more detail, the first line inputs a number and stores it in the accumulator. Number 2 outputs the contents of the accumulator. We've got that in there early, so it says 10, 9, 8, 7, 6, rather than just going straight and saying 9. We then store the accumulator value, so what was in the accumulator gets stored into the variable start. We then sub the value 1, because that's what decrement stored as, and then we output the values. That's when we say 9 for the first time. We check, is 9 0? No, it's not. So we go on to BRP, which checks if it's a positive number, which it still is, because 9 is positive, so then jumps straight back up to counter and continues until it gets to 0. And that is pretty much it. Now this is the hardest part, I think, of your LMC, is thinking about how your branching works. So if I look at my program, if I just very quickly go to here, here's the same program, exactly the same. I'm just going to make that capital because it's annoying me. But if I switch these two around, so I go from there like that, let's look how the program runs. So we'll put 10 in again as normal. So it says 10, 9, 8, 7, 6, and so on. But then we get a -1 in there. And that's what's really important, and that's what can throw you off. Because the first time I wrote this for this video, I had it this way. So I'm saying, well, whilst it's positive, but because it's 0 counts as positive in LMC, it goes, all right, oh, it's 0 still, that's a positive number. So it does it, subtracts the extra 1, so it goes to -1, and then just goes, all right, well, I'll just end, and it finishes, and the accumulator is -1, which is incorrect, because as soon as a condition isn't met, what it does is it just goes to the next instruction. So what actually happens is it does a BRP counter, doesn't work, so it goes into BRZ end. Well, it's not 0, so it goes to end, so it ends up going to end anyway. But if I had some other instructions in there, then that would break the program. If I had just some extra bits that it wasn't supposed to do, let's say, I don't know, it's supposed to loop the whole program again, well, it wouldn't just carry on. Okay, so it's really important that your sequencing of your instructions makes sense and is correct. So that's the most difficult thing with this exam, is that you don't have this emulator that you can use, which is a bit unfair. So writing out these programs is really important. So those are your 3 branch commands, and that is all the commands you need for the exam. So what I recommend you do is look at some past paper questions, practice writing them out. The most common thing you're going to get is explaining what each command does. That's your first one. Your quite common one is talking about which ones change the accumulator. So that is like your inputting, your adding, your subtracting, your loading. Which changes the program counter, which is your branching. And then the other one is tracing an LMC program to find out what it does and then give an answer. So it might be like a bubble sort, for example, and you'll get that out from the answers rather than the actual program itself. Or they might ask you to convert an LMC program into a high level language. So whatever programming language your teacher's done, or if you've been taught by me or been using my videos, into JavaScript, which is still very easy to do, but you have to understand the program. You need to know, because what you don't want to do is go convert every single line by line, because more often than not you're going to be able to write a loop better than programming it how you would do like a BRZ, for example. And that's what a lot of my students that don't really pay attention, don't really understand assembly language, they end up converting it and they're sort of right, but they could simplify the program a lot further, which usually means they lose a mark. However, I've spoke for way too long. This is the longest of the 3 videos. So I'll see you in the next video.